In this problem, we're being asked to use the ratio test to determine if this series converges. So the ratio test says if you take the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n, three things can happen. One, if this limit is less than 1, then the series will converge. Two, if this limit is greater than 1, then the series will diverge. And if this limit is equal to 1, then we have no information. So in this problem here, your a sub n is this entire piece here. So all we have to do is work out this limit and see what the result is. So we take the limit as n goes to infinity of the absolute value. So a sub n plus 1 basically means you replace all of the n's with n plus 1's. So we have 9 over and then n plus 1 factorial. Now we have to divide by a sub n. So instead of dividing by a sub n, what we do is we multiply by the reciprocal. It's a little bit easier. So you just flip this. So we have times n factorial over 9. So again, step 1, you replace all of your n's with n plus 1's. That puts you here. And then we're dividing by a sub n. But instead of dividing, we tend to multiply by the reciprocal. Notice the 9's cancel. And then something beautiful happens here. N factorial is equal to n minus 1 times ... 3, 2, 1. N plus 1 factorial is equal to n plus 1 n minus 1 times ... times 3, 2, 1. So notice you can write this as n plus 1, and then this piece here is actually just n factorial. So you can always do that. So you can write this as the limit as n goes to infinity of, we can drop the absolute value. There's no x's or anything. Everything here is positive. There's nothing here that could possibly be negative. So we can drop the absolute value. So you have n factorial over, and then here we have n plus 1, n factorial. Using this, right? n plus 1 factorial is n plus 1, n factorial. And these cancel. So we have the limit as n goes to infinity of 1 over n plus 1. So when n gets really, 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 really big, this fraction gets really, 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 really small. So this approaches 0. And that's less than 1. So the series, it's important to explain what's going on in these problems. So the series converges by the ratio test. So by the ratio test. Whenever the limit is less than 1, we get convergence by the ratio test. If it's greater than 1, we get divergence. And if it's equal to 1, we get, unfortunately, no information. I hope this video has been helpful. Take care.